Hello students, let us go through one more sum based on speed, distance and time. The sum is a boat travels 16 kilometers upstream and 24 kilometers downstream in 6 hours. The same boat travels 36 kilometers upstream and 48 kilometers downstream in 13 hours. Find the speed of water current and speed of the boat in still water. As I always say, initially don't try to understand anything, just read the last statement, and the last statement says find the speed of the boat in still water and speed of the water current, right? So let the speed of the boat in still water be x kilometers per hour and let the speed of the water current be y kilometers per hour, right? So we know there are two unknowns. There is a boat which is moving with a speed of x and there is water current which is moving with a speed of y, right? Now in this sum there are two important words and those are upstream and downstream. So before we move on in this sum, we need to understand what exactly do we mean by upstream and what exactly do we mean by downstream. See, may it be electric current or water current, it always flows from a higher level to a lower level, right? Now say for example, this is the higher level to lower level. This is the direction of the water current, okay? Water is flowing like this. Now when they say boat is moving upstream, upstream meaning up the stream, lower level to higher level, right? So this is the direction of the stream, this is the direction of the boat. So when we say that boat is moving up the stream, that is boat is moving in the direction opposite to that of the stream. So always remember this. When we say boat is moving up the stream, that is boat is moving in the direction opposite to that of the stream. In other words, this is like you are moving ahead and somebody is trying to push you from the front. So you are moving ahead with your speed, say your speed is 10 kilometers per hour, okay, and somebody is trying to push you from the front. Now because of this push, will your speed increase or decrease? It will definitely decrease, right, because of this resistance. Now how will it decrease? Now say your speed is 10 kilometers per hour and somebody is trying to resist you with a speed of 3 kilometers per hour. So your resultant speed will be 10 minus 3. So your resultant speed will be 7 kilometers per hour. Similarly, the boat is moving with a speed of x and stream is opposing with a speed of y. So the resultant speed in upstream will be x minus y. Is this thing very clear? So always remember this. If the speed of the boat in still water is x and speed of the stream is y, speed of the water current is y, then speed of the boat in upstream will always be x minus y kilometers per hour. And downstream is exactly opposite. Downstream meaning the boat and the water current both are moving in the same direction. That is, you are moving ahead and somebody is pushing you from behind. Now because of this push, your speed will definitely increase, right? So in downstream, the speed of the boat is always equal to x plus y kilometers per hour. So these are four important statements as far as this sum is concerned. The first statement is let the speed of the boat in still water be x kilometers per hour. Speed of the stream be y kilometers per hour. So speed of the boat in upstream will be x minus y kilometers per hour and speed of the boat in downstream will be x plus y kilometers per hour. So upstream, opposite direction, downstream, same direction, right? And when we say still water, meaning there is neither any resistance nor assistance as far as water is concerned, boat is moving with their original speed, right? Now we already have assumed the speed, so what remains is now distance and time. Now to understand that, let's again learn it in a tabular form. This time it is all about upstream and downstream and speed, distance and time. Now speed upstream we already know is x minus y, speed downstream we already know is x plus y. Now if you read the question properly, a boat travels 16 kilometers upstream and 24 kilometers downstream. Kilometers, distance. So distance upstream is 16 kilometers, distance downstream is 24 kilometers. Speed we assumed, distance is already given, so what remains is time. So how do we find the time? The formula time is equal to distance upon speed. So time upstream will be 16 upon x minus y hours and time downstream will be 24 upon x plus y hours. And what is given? A boat travels 16 kilometers upstream and 24 kilometers downstream in 6 hours. So can we say this 6 hours is nothing but the total time taken by the boat to move 16 kilometers upstream and 24 kilometers downstream? Now time taken upstream is 16 upon x minus y. How did we get this? Using the formula. Time taken downstream is 24 upon x plus y. The total time is 6 hours. So your equation is 16 upon x minus y plus 24 upon x plus y is equal to 6. Very, very easy, right? Now the second condition is also quite similar. The same boat travels 36 kilometers upstream, 48 kilometers downstream. So now the time taken upstream is 36 upon x minus y hours. Time taken downstream is 48 upon x plus 5 hours, and the total time, as you all can see, is given as 13 hours. So your second equation will be 36 upon x minus y plus 48 upon x plus y is equal to 13. Very, very easy, right? Now let's solve the two equations, the first equation and the second equation. What type of equations these are? Variables in the denominator, right? And whenever there are variables in the denominator, what we need to do is we need to go for substitution. So let's see what is to be substituted. 16 upon x minus y can be written as 16 into 1 upon x minus y. 24 upon x plus y can be written as 24 into 1 upon x plus y. Similarly, 36 into 1 upon x minus y and 48 into 1 upon x plus y, something which we already know, right? And if you will remember, I said this step is not compulsory to be done in the exam, it is only for your understanding of what we are supposed to substitute, right? Now, what is common? 1 upon x minus y and 1 upon x plus y, and because 1 upon x minus y and 1 upon x plus y is common, let us substitute 1 upon x minus y is equal to m and 1 upon x plus y is equal to n. Let's do the substitution in equation 1 and 2. In the first equation, when we substitute, we get 16m plus 24n is equal to 6. Let this be equation 3. The next equation will be 36m plus 48n is equal to 13. Let this be equation number 4. Now look at the third and the fourth equation. We need to solve it by the method of equating the coefficients. For that, check the coefficients of m. The coefficients are not the same. Check the coefficients of n. The coefficients are not the same. So we'll have to either make the coefficients of m same, or we will have to make the coefficients of n same. Look at the coefficients. I feel it is better that we make the coefficients of n same by multiplying the third equation by 2. Let's multiply the third equation by 2. We get 32m plus 48n is equal to 12. Let this be equation number 5. Now look at the fourth and the fifth equation, where the coefficients of n are already the same, right? So we can easily eliminate n by subtracting, because the signs are also the same. Subtracting equation 5 from equation 4, what do we get? Write the fourth equation, write the fifth equation, subtract, change the signs. Plus 32n becomes minus 32n, plus 48n becomes minus 48n, and plus 12 becomes minus 12. Plus 48 minus 48 gets cancelled. 36m minus 32n, 36m minus 32m will be 4m, and 13 minus 12 is 1. 4m is equal to 1, so m is equal to 1 upon 4. Once we get the value of m, let us substitute this value of m either in the first or the second or the third or the fourth equation. Not in the first and second, right? Only either in the third or the fourth equation. The choice is yours. Now if we substitute m is equal to 1 upon 4 in the third equation, what happens? We get 16 into 1 upon 4 plus 24n is equal to 6. Now 4 4s are 16. We get 4 plus 24n is equal to 6. We get 24n is equal to 6 minus 4. We get 24n is equal to 2. We get n is equal to 2 upon 24. We get n is equal to 1 upon 12. We get the value of m. We get the value of n, but the sum is not over, because we are interested in the values of x and y. I hope you all remember this, right? And how do we get x and y? Wherever there is a substitution, there has to be a resubstitution. So let's resubstitute and get the values of x and y. How do we resubstitute? We substituted 1 upon x minus y as m. We got m as 1 upon 4. So 1 upon x minus y is equal to 1 upon 4. We substituted 1 upon x plus y is equal to n. n is equal to 1 upon 12. So 1 upon x plus y is equal to 1 upon 12. After resubstitution, I hope you all remember that we take the reciprocal. So let's take the reciprocal. 1 upon x minus y is equal to 1 upon 4. So x minus y is equal to 4. We are getting one more equation. Let this be equation number 6. Similarly, 1 upon x plus y is equal to 1 upon 12. Take the reciprocal, we get x plus y is equal to 12. Let this be equation number 7. Luckily for us, we are getting two simple equations now. Let's add the two equations and get the values of x and y. When we add equation 6 and equation 7, plus y minus y will get cancelled. X plus x will be 2x, 4 plus 12 will be 16. So you get x is equal to 16 upon 2. So x is equal to 8. Once we get the value of x as 8, substitute x is equal to 8 either in the 6th equation or the 7th equation. If we substitute in the 7th equation, we get 8 plus y is equal to 12. We get y is equal to 12 minus 8. We get y is equal to 4. X is 8, y is 4. The final answer is, therefore, speed of the boat in still water is 8 kilometers per hour and speed of the water current is 4 kilometers per hour. As simple as that.